Pre-calculus student, in this video, I'm going to talk about how to verify trig identities. So know the difference between simplify and verify. So if it is asked simplify, which means you are given something, you don't know what's the answer. And if they say verify, which means you are given both sides and you start from one side, you begin with the other side. So simplify and verify. So in this, the good news is you already know what you are looking for. The answer is what you are looking for. So this is my favorite sentence is one needs to have sense of adventure and fearless attitude. Try something. Don't just keep staring at it. Have to know some basic ideas and then you have to apply. So what's the purpose of this? Again, you need lots of practice and learn what is called algebraic manipulation. Before we start work, you have to know those identities. So make sure you have a list of all identities with you mentally or on the paper, whichever way. So these are three basic Pythagorean identities. We already know all those sine, cosine, tangent, reciprocals. You need to know how to combine fractions and how to perform algebraic expressions, add, subtract, multiply, factor. Of course, this some of you would say this is a long list, but well, I would say again, don't just sit and stare. Do something, do something, do something. So we are going to look at a few examples here, and each and every one have a different approach. So this one, you always start from one side. Do not work parallel. Do not work parallel. Begin from one side. I'm going to point out again. Begin with only one side and with the other, and with the other. Begin from one side and with the other. So for example, here, more complicated side is the left side first. So what would you do is distribute. Think about you have A, B plus C, D. What would you do? So you get AB plus ACD. Basic algebra. We are doing calculus. I mean a pre-calculus. Now come to trigonometry. So you can say, I would say sine x times cotangent x plus sine x times cosine x times tangent x. Do not skip the angles. You must have x. Do not ever write sine, cotangent plus. This is wrong, wrong, wrong. We don't call this trigonometry. We don't call it trigonometry. Okay, so now what do? We are looking for two terms. So we know that cotangent is cosine over sine. Sine, basic, you can't do anything. Cosine, you can't do anything. Tangent is sine over cosine. Clearly, this sine and sine get cancelled out, but do not cross out anything. You are saying divide out by 1. You can say divide out by 1. You can say divide out by 1. So left is a cosine x. Here cosine, cosine, you can't just say cross out. Do not cross out. You can just say sine square x. Isn't that what I'm looking for? So that means you are done. Okay, so let's try other. And there are so many practice problems. You have to apply what you know. You have to apply what you know. So I'm going to explain this by already my written work here. So first of all, these are the two. This is one. So sine, cosine, tangent plus sine, cosine, cotangent. 2 times 1 is a 3. 2 and 1 is again 3. Sine and cosine, you can't do anything. Tangent is very similar to sine over cosine. Sine, cosine as it is. Cotangent is cosine over sine. This is very similar to the previous one. But we are trying to prove the answer is a 1. So I would again say do not cross out. You can say cosine, cosine divide out to 1. If you think this is same, extend the line if you want to. So these two, sine square, cosine square, and sine square plus cosine square is a 1. Check off. Alternate method is a here. Please check the notes. What you could do it is, you can work on the parentheses, combine the fraction, sine square, cosine square, denominator is cosine times sine, 1, and these two divide out is 1. Okay, so this is a super cool uh, identity. We are trying to get the answer negative tangent square. So we know that cosine square plus sine square is a 1. Now this is cosine square minus 1. So cosine square minus 1 is negative sine square. 1 plus tangent square is a secant square. Secant square is 1 over cosine square. Negative sine square over cosine square is tangent square. Okay, so all your work has to be mathematically correct. If you do not want to put equal to equal to equal to, that's fine, as long as you are working on one side and end with the other side. That is considered mathematically correct. So let's flip the paper and we look at some more examples here. Okay, so explaining this one here. Okay. What is 1 over tangent is a cotangent. Tangent as a tangent. I'm explaining and explaining why we did certain way. You could also combine this fraction here and you could say 1 plus tangent square over tangent. That is also alternate way to do it. Remember, you can't touch this other side. So you are working only on one side. So cotangent is cosine over sine. If you don't like a beta, well, you have to use given variable. Don't change the variable. Tangent is a sine over cosine. Common denominator is a sine times cosine. Common denominator is sine times cosine, which means this needs to be multiplied by cosine. This needs to be multiplied by sine. Cosine square plus sine square, which is 1. And now this is very interesting. 1 over sine beta is cosecant. Then 1 times 1 is a 1. So 1 over cosine is a secant. 1 over sine is cosecant. And 1 times 1 is a 1. So think again, if you have 1 over a times b, you can also say 1 over a, 1 over b. Algebra skills are very important. You have to know how to do all of this. Okay, so let's talk about fraction. Giving you example, if you have 1 over a minus and 1 over a plus 1. How do you combine these two fractions? We learned this in algebra 2. So clearly, common denominator is a minus 1, a plus 1. Same thing here. Secant x plus 1, secant x minus 1. Multiply secant x plus 1 plus secant x minus 1. This becomes 2 times secant x over this 2. Okay, shouldn't cross out. 1 minus 1 is a 0. And this becomes secant square x minus 1. How? Okay, again, expectations. You know that difference of square is a square minus b square, which is secant square minus 1. Or you can FOIL it. You can multiply. But again, know that this is a very, very popular in trig, that it is a difference of square. Okay, so secant square minus 1 is tangent square. 2 times secant x. You are looking for 2 times cosecant and secant. So you already got the 2. Okay, secant and tangent. So 2. Secant is 1 over cosine x. And tangent is actually, you can say cotangent and you can say cosine x over sine x square. Okay, so one more time here. 2 times A over B. You can also say 2 times A times 1 over B. Okay, so what do? We can clearly see one of the cosine get divide out. So 2 cosine, and there are two signs here. So 2 times cosine x over sine x times sine x. Think of this way. And 2 is there. This becomes cotangent, and 1 over sine becomes cosecant. So what I did here is, let me explain you already written form here. And you have to have a really good algebra skills to understand. This is considered one of the hardest problem. So less likely this could be in the AP exam. The reason is because of the grading difficulty. But I would highly recommend that you do it because it's a really, really good practice for combining fractions and using identities. Okay, so let's talk about this is considered one of the easy one, and I would highly, highly, highly recommend that you try yourself, foil it, and see what you could do. I would like to explain here. This is one of the super cool identity we call them, is how can difference of two square become product of two square. Where do you use this? In whenever we have to replace these two terms as a single terms in calculus. So let's begin this. Sine square x over cosine square x minus sine square x over 1. Combine fractions. Cosine square x, sine square x minus sine square x times cosine square x. Okay, so I'm having a hard time to write down, so I'm going to explain from my written work here. And I'm going to explain. So we applied common denominator, factor out sine square. So which makes it 1 minus cosine square. Now cosine square plus sine square is a 1. So 1 minus cosine square is sine square. So let me highlight. This space became this. Sine square over cosine square is back to tangent and sine. So big picture, let's talk about the big picture is, how do you know what to do this? Because we are given 2, 1 can be written as a fraction. So combine the fraction, factor out, write as a product. Write as the product. Okay, so we have a couple of more examples here, and we can, I'm just going to show you from my existing work here and explain. So cosecant minus sine, again, difference we want as a product. So how do you know what to do? Well, combine as a single fraction. So 1 over sine, sine over 1, combine as a single fraction. This is considered as a single fraction, single term. What is 1 minus sine square is a cosine square. This is a so popular identity that I call it a celebrity. Celebrity means everybody know them, everybody use them. We know we have to spot them. That's why I call them celebrity, is you have to spot them. 1 minus sine square, straight away, cosine square. Now you want product of two functions. You don't want square. So how do you split this? You split cosine times cosine. You don't want any squares. So cosine over sine is cotangent, and leave this cosine as it is. So algebra skills, if you have a square over b, how can you split? Well, I don't want any squares. Can I write like this? Yes. Well, keep one of the a as it is. What is a over b? Is a c. Think of that way. So that's the strategy we are using here. Okay, so now this number 10, you can work on number 9 on your own. Again, distributing. This is one of the easiest one. I would say that you can pause the video and check this. Let me explain my favorite problem. This is my favorite problem. I have been saying why it is my favorite problem. So let's think about fourth and square. So going back on the side, a to the fourth minus a square, you can factor out a square minus 1. Okay, so you are not allowed to touch. This question has been many, many times in our assessment, but many students are just working both sides, never touch the other side. So, and this is doable on both sides. So I'm showing you one from this side, secant square, factor out secant square minus 1. Now, identity is 1 plus tangent square theta is a secant square theta. So, secant square is replaced as 1 plus tangent square, and secant square minus 1 is replaced as a tangent square. And now you distribute again, and you get super cool tangent square plus tangent to the fourth. So this is the reason I like, this is my favorite problem, is we can't think of using same identity used twice in the same step. The same step, we are using same identity twice. Once we are using in this form, second you are using in the other form, and then distribute. So let me explain how this would look like if I start from the other side. Okay, so I'm starting from the other side, tangent to the fourth plus tangent, sorry, my bad, I'm just starting from the other side. Tangent to the 4 plus tangent square. I factor out tangent square. So tangent square x plus 1. We just talked about tangent square plus 1 is a secant square. And tangent square is secant square minus 1. And now distribute. Distribute. So you will get secant to the fourth minus secant square, which is my left hand side. So the same questions, I started from the right side, ended with the left side. So super cool problem, my favorite one. I hope you understand something on this. And the only way to get mastery on this is practice, practice, practice. Get over the fear. Have some sense of adventure. That's the fun part, not to avoid it. Thank you.